Continuing with section 5.5. So in the first video, you learned how to solve basic trig equations. And just note here, if you get something like this equation, cosine of t is equal to 2, then there is no solution. And the reason is that there is no value t, no real number t such that the cosine is equal to 2. Because the maximum value the cosine function can take is 1 and the minimum is -1. In the same way, sine function, the maximum value is 1, the minimum is -1. So if you see these numbers outside the interval -1 to 1, then the equation will have no solution. Okay, so now we are going to talk about the inverse functions. So recall in section 2.8, we learned that if a function is one-to-one function, then there will be an inverse function of f, and we denote it by this symbol, and we read it as f inverse or inverse function of f. So now the question is, what are the one-to-one functions, or which functions can be called one-to-one? So these are the functions whose graphs satisfy the horizontal line test. I mean, we can check algebraically as well if a function is one-to-one or not, but graphically it's quicker. So if you see, if you draw a horizontal line and it crosses the graph in more than 1 point, then it is not one-to-one. So for example, the graph of x square does not satisfy the horizontal line test. So x square, f of x is equal to x square is not one-to-one. Whereas the graph of x cube is one-to-one. Okay, so that's what the horizontal line says. So now we want to see if we can create a inverse sine function, inverse cosine function, and inverse tangent function. Now, looking at the graph of the sine function, we notice that this is not a one-to-one function, because if I draw a horizontal line, it crosses the function in infinitely many places. So what do we do to find, because inverse sine functions are actually inverse sine functions and inverse cosine and inverse tangent are useful in many real life phenomena. So we see that we can define a inverse sine function by restricting the domain of the sine function. So how do we restrict it? Thinking about, we want all the values of the range in our function. So the domain we pick such that all values of the range are in there, and also the piece of the function is one-to-one. For example, if I take the piece between 0 and pi, it is going to be this piece, and this is not one-to-one. And also it does not take up all the values of the range. So what we do is, you notice that as if we take the restrict the domain between -pi/2, so this is pi, -pi, this will be -pi/2, and this will be pi/2. So if we restrict our domain here and discard this rest of the piece, so we are looking at this piece between -pi/2 and pi/2, this is one-to-one, and it is going from -1 to +1. So then we will define the inverse sine function on this piece. So restricting the domain to negative pi over 2 to pi over 2, if you look at it, this in the terms of the circle, unit circle, we say our t should lie in this region. So when we are looking at the sine, we are looking at this region. Okay, so we say now we can define the sine inverse function. So we write it like this: sine function inverse sine function. So we can call it sine inverse or inverse sine. So inverse sine function is the function we read it as sine inverse x or inverse sine x. So we sine inverse x such that y is equal to sine inverse x if and only if. This symbol is for if and only if. So what does that mean? It means if we have this equation, we can write that equation. And if we are over here, we can go to this side. So it goes both ways. So it's like if you recall the logarithmic and conversion between logarithmic and the exponential form. So here it is between sine and sine inverse. When we have y is equal to sine inverse x, if and only if sine of y is equal to x. So the domain of the sine inverse sine function is going to be negative 1 to 1. Why? Because remember here in this piece, this small piece that we extracted after restricting the domain of this one is negative pi over 2 to pi over 2 written here, and the range here is negative 1 to 1 including the endpoint. Now when we talk about the inverse function, again in 2.8 we mentioned this, that the domain and the range, they reverse. So this is true for the sine y is equal to sine x, or f of x is equal to sine x. But for y is equal to sine inverse x, for the function y is equal to sine inverse x, the domain will be the negative 1 to 1 and the range will be negative pi over 2 to pi over 2. That's what is written here. Okay, the graph of sine inverse looks like this. You don't have to worry about the graph a lot, but this is how it looks. There is another notation that we use sometimes. This is the name. This is the notation we use for the inverse sine. So instead of writing it like this, we can write arc. We write it like this, but we read it arc sine of x. Now, very, very important thing here, you have to understand that this is not true. In other words, I told you that when we have n is greater than 1, 0, then sine to the n of x is the same thing as sine of x whole raised to the n. Now here we are talking about sine. We don't even say sine to the negative 1 x. We say sine inverse x. This is not equal to sine of x whole to the negative 1, which is the same thing as 1 over sine x. Remember 1 over sine x? Is equal to the secant x. Okay, so let's look at some examples here. So it's saying find the exact value of each expression First one is sine inverse x. So what are we trying to find here? So we are looking for a real number t or x, you can call it whatever. We can also do it like this. We say, okay, let's say we want to find this value and we don't know. So let's set it equal to x. Then by definition, remember we had a definition that y is equal to sine inverse x if and only if sine of y equals x. So following that, here I can say now, I'm saying sine inverse of 1/2 is equal to x, means sine of x equals 1/2. In other words, we are trying to find a real number x in where? In negative pi over 2 to pi over 2. So we are looking for x in here such that this happens, such that the sign of that is equal to 1. In other words, if you notice, this is like solving a simple basic trig equation. We are looking for the solution of this equation in this interval. Remember, if I ask you to solve this equation, there are infinitely many solutions. But when we are writing this equation from a inverse function, then we are looking only for one value. So what value is in between negative pi over 2 to pi over 2? So you can think of it like on the number line. This is negative pi over 2, and this is pi over 2. Somewhere here will be 0. So what number between these two values is going to give us the sign of that number is equal to 1/2. So that number is pi over 6. So only one value. So which means sine inverse of 1/2 equals pi over 6. In the same way, now looking at the next one. So arc sine square root of 2 over 2, we want to find, basically we are looking for a number such that sine of that number, it's your choice what you call that number, t or x, or there is another symbol that you will learn in chapter 6, which is this symbol. What is that symbol? That is theta, the Greek letter theta. So we can use any variable, any symbol here. We are looking for theta, so that sine of theta equals square root of 2 over 2. But what is the restriction? That the theta must be in the region, in this region. So it must be either in the 4th quadrant or in the 1st quadrant. So what is that? Pi over 4. Okay, number 3rd. So there is not much work here, more like a concept. Next is sine inverse of 0. So again, remember, we are looking for a value or a number t such that sine of t equal to 0. So when is sine 0? Remember, sine is 0 over here and it is 0 on this, when t is equal to pi. But which one will I pick? Well, we have to remain in this region, so our t will be 0. Okay, in the same way, we can define cosine inverse or inverse cosine function. And how do we do that? We have to restrict the domain. So we try to see if we have to restrict the domain to the same. Can we do it that way, or will it be different? So notice now here, the negative pi over 2 to pi over 2 will not work. Why? Because it does not give us the one-to-one function. So what should we do? Well, should we take it from negative pi to 0? Yes, we could do that from negative pi to 0. But when we can do a positive one from 0 to pi, why pick the negative one, right? So easy is the 0 to pi. So we pick this piece 0 to pi. It is given here separately. So the range is from negative 1 to 1. In this case, this is a piece of cosine x with domain negative 0 to pi, including the endpoints, and range is negative 1 to 1. So on this one, we define the inverse function. Same thing, cosine inverse function. We say y is equal to cosine inverse x if and only if cosine of y equals x. And the domain and the range get reversed. So the domain of the cosine function was 0 to pi. That will become the range of the inverse function, and the range of the cosine function, which was negative 1 to 1, will become the domain of the cosine. Here is the graph of the cosine. Again, you don't have to worry about the graph. You will not be asked to graph the inverse functions. Again, the warning, you have to be careful and understand this notation. The cosine inverse x is not cosine of x whole inverse. Okay. So now to look at some examples again. Find cosine inverse of 1/2. Cosine inverse of 1/2. So what are we looking for? We are looking for a value or a number or a real number t such that cosine of t is equal to 1/2. But where should t be? Between 0 and pi. For cosine, we are looking or on the number line 0 to pi. So we are looking for in here. So we are looking for t such that cosine of t is 1/2. So if you recall, this happens when t is pi over 3. Remember, it also happens when t is 5 pi over 3, means t is in the fourth quadrant. But we are not at this time with the cosine. The fourth quadrant is not included in the range. So we have t is equal to pi over 3, or cosine inverse of 1/2 is equal to pi over 3. Next one, arc cosine of square root of 2 over 2. Again, it's your choice. You can call it t or x, whatever. Then by definition or our understanding, that we are looking for the number t such that cosine of t equals square root of 2 over 2. In other words, we are trying to solve this equation, but the solution must be in 0 to pi. So arc cosine is when t is pi over 4. Next one, cosine inverse of 0. So in other words, we are looking for a number t such that cosine of t is equal to 0. And where is that? Does that happen? It happens when on the unit circle, when our terminal point is over here at pi over 2, or terminal point is at 3 pi over 2. or negative pi over 2. But remember, we are not supposed to look down here. We have to stay above the x-axis or between 0 to pi. So the answer will be t is equal to pi over 2. Okay, going on with the tangent, we have a similar situation. We will restrict the domain, because without restricting the domain, if we look at the actual tangent function, it is not 1 to 1. It does not satisfy the horizontal line test. Okay, so looking at the graph of the tangent, this is how the graph looks like. So you can see there are a bunch of pieces, infinitely many pieces of the function between asymptotes. So there are some asymptotes here involved. What we do is pick the middle one, which passes through 0. And so the asymptotes are x, this one is x is equal to negative pi over 2. This is x is equal to pi over 2. And we have a piece like that. So this is 1 to 1. And we see that the domain here is negative pi over 2. So this is y is equal to tangent x, or f of x is equal to tangent x. And the domain here is parentheses negative pi over 2, comma pi over 2. So note that the negative pi over 2 and pi over 2 are not included here. That is the difference between this and this domain that we had for the inverse sine function. And the range is, in this case, all real numbers. So now we define the inverse tangent function. In the same way that we have done before. So it will be so y is equal to tangent inverse x if and only if tangent of y is equal to x. Okay? This is the definition. And what will be the domain of the inverse function? The negative infinity to infinity. And the range of the inverse tangent function will be the negative pi to pi over 2 to pi over 2 with endpoints not included. Okay. Now look at the graph of the tangent inverse. Now this graph actually I will ask you to keep in your in your thoughts. This is something that you will notice. It will be helpful in the future, like in calc 1 will be used a lot, and sometime maybe in this class as well. The same things with the notation arc, tangent arc, cosine arc, sine. That is another notation. And here is the graph of tangent inverse. So remember, in the tangent x, the restricted, we had vertical asymptotes. Now we have horizontal asymptotes. Okay. So let's look at examples. The same thing that we have done before. Tangent inverse of 0, that's something we want to find. That means we are trying to find a number t such that tangent of t is equal to 0. So when is the tangent 0? Tangent will be 0. Remember, tangent is sine over cosine. Tangent t is equal to sine t over cosine t, which means that it will be 0 when sine is 0, when the sine of t is 0. And when is the sine t 0? When t is 0 or pi. Yeah, I think I will stop here and we start doing this example in the next video.